Hi everyone, and welcome to another session of Seneca Quimica. And we're looking at a very simple single replacement reaction, something you'll see in any high school general chemistry or entry-level chemistry. We're going to look at some advice and some observations and the content too, of course. And we're going to use a copper compound. Copper compounds in solution oftentimes are blue. That's a good clue that you have a copper compound. It's very simple. You just take some, put it in a test tube. Here we have copper 2 sulfate. And just to know for teachers, copper 2 sulfate works a lot better for the single replacement reaction with iron. And the reason is because it tends to make iron 2 sulfate. If you look at any standard table of reduction values or activity, you'll see that it's the copper 2 ion and the iron 2 ion. Iron 2 sulfate is very soluble and it will work. So we're using copper sulfate, copper 2 sulfate to do the reaction. Iron 3 sulfate is not soluble and probably it won't work with this reaction. You might be thinking you can use, what if I use copper nitrate? Then it'll make iron nitrate, and iron 2 nitrate is not found in nature. So you have this positive 2 ion trying to make iron 2 nitrate. That won't work. So using copper nitrate won't really do the trick either. So the trick is using copper sulfate for your reaction with iron. Here I have some iron right here. And very simple, of course, you just put it inside the tube, push it down to the bottom, and that's it. It's ready to go. For the iron, I'm going to use a piece of steel wool. Steel wool is anything you can get at the store, in the cleaning section, like a Brillo pad or something like that. Surface area is key, and here you have a very finely made piece of iron. And you can just pull it apart and use that as your iron. So here I have my test tube with the iron metal going to be pushed down, and it's in copper sulfate, and the reaction is quite rapid. So here we go. I'm gonna just watch it and push it down. And you can see already that the color is changing in the iron. The iron was this grayish color, but now it's quickly becoming this reddish color. So I'm moving a little closer here. The reddish color comes from the copper. The copper in the solution is becoming a solid, forming on that iron, and that is the copper. Meanwhile, the iron is going into the solution, and if I leave this in here long enough, all the gray part of it will be gone, and you'll just be left with this reddish stuff. And again, as the copper leaves the solution and is formed as a solid, what happens is the color will go away. The bluish color, here it was this nice bluish color, but over time it'll start to become kind of greenish as you get this iron sulfate instead in the solution. So because the reaction is occurring, that tells you that iron is more active or higher on the potential list than copper. So here it is in the test tube without the solution, and it's kind of dry now. You can see it's basically copper left over. And here it is on the scupula. You can see it does not look like that iron steel wool anymore. It's basically all just this brownish stuff, and that is the copper metal. Again, steel wool is great because it's very thin, has these thin shreds of iron. That's great for a lot of surface area for the reaction to occur, and the reaction happens very quickly. Again, because iron is more reactive than copper.